And one issue I think we had in last class of UART polling, correct?
Yes.
Okay. So first we will see that polling method. Then we'll shift to our new topic that will be I2C. Fine. So I'll just share my screen and show you how the UART polling works. I have already shown you all how UART in interrupt mode works, correct? So polling is easier than that, nothing much to worry. Tell me once my screen is shared.
Yes, visible.
Okay. So in polling mode, what we do? We just transmit the data and receive it without any interrupt or using of TMA, correct?
Yes.
Okay, so just go there and create a STM32 project. Then here we will select our controller. Doing it fastly because we have already covered these topics. But if anyone found any difficulty or any issue, then you can speak. I'll give it name UART in polling. Fine. Then I'll finish it. Do you remember on which pin our UART, RX and TX were located?
PB5 and PB6, I think.
Okay. It's correct. Now I'll just go in connectivity. UART 1. Use it in asynchronous mode. And I want UART to use in polling method. So I will keep all the parameter setting as it is and will not enable this interrupt. Fine.
Yes.
Just here change the pins PB5 and PB6. PB5 is my it's UART 1 TX. It's not PB5 and 6, it's PB6 and 7.
Okay, sorry.
Okay. So we have configured PB6 and 7 as UART, RX and TX. Now we will generate our code. This interrupt will come. Here I will take one RX buff in this. I'll store the data to be sent. So I'll just keep my name here. Fine. Or it's not RX, we will send it, so it's TX buffer. Then in while one loop, we will transmit. So I'll write like all UART transmit. For polling mode, we will select the first one. In this, we will select we are using UART 1. Our data is in TX buff. Size of data will be size of TX buff. And timeout. Yeah, one more thing. In interrupt, we were not using timeout, correct? Hello?
Yes.
sir.
In interrupt mode of UART, were we using timeout or not?
No. No.
But here
No.
we will use. Because what happens in interrupt, every time the interrupt will be generated, it will transmit or receive the data. But here no such interrupts get generated, so we have to fix the timeout.
Okay.
Timeout I will keep maximum, so that will be 0xff. Fine.
What is 0xff, Chandan?
Its maximum value. You can search its value. Do you know something like hexa value, decimal value, hexa value?
No.
So just Google it and search hexa value, decimal value, binary value. You will get to know it.
Okay.
And for embedded coding, hexadecimal values are important.
Okay.
Sorry.
255 the value of J.
Yeah. Its value in decimal is 255. But for his understanding, once if he can search it and Google it, then it will be better for him.
Yeah, I
You are
got
from
it.
you are from CS branch, I think.
Yes.
Yeah, so there in C programming and C++ programming, there is one topic that there we program like we have to convert decimal value into hexadecimal value, octal value, and all. Yeah, so just Google it and check how to what does the hexadecimal values means in binary form and decimal form. You will get to know this.
Can you once repeat why we are using 255 here? Like time dot, what does that indicate?
Sorry, there are so much disturbance from your side. If it's regarding that 0xff, that's the maximum value which we are using, but you can use any value like 100, 200, 300, any value. But for 8-bit, it's 256, I think, and -1 it's 255. So I'm using that. You can use any value.
Chandan, sorry to interrupt, but how to decide when to use hexadecimal and when to use decimal value? Is it?
At the most places in embedded, you should use hexa value, because when you will debug your code, all the
Okay.
values that you will get will be in hexadecimal values. And in later parts, when you will write the codes for some external sensors using registers and all the
Okay.
values of registers are given in hexadecimal value only. In big sensors data sheet, all these values will be present in hexadecimal. 90% will be present in hexadecimal, 10% will be in normal value, decimal values.
Okay, got it.
It makes processing fast, so that's why we use.
Oh, okay, that's the case. Okay, fine. Okay.
Now I'll use hard delay 1 second. Fine, my code is good.
Sir, what does this timeout indicate, sir?
Timeout means timeout after which it will like it's something like delay for UART function. This delay which we are using, it's once the transmission is successful, then it will wait for that 1 second, but this timeout is internal timeout for UART. So the function UART will repeat its process after this timeout.
Fine.
And now we have built our code with 0 errors and 0 warning. I'll just run it. Okay, I'll have to connect my board. We are good to go. Let me open Doclight. Heritage. I'll check my COM port. So it's 16. My COM port is set on 16. Baud rate 115200, which is default. So I'll just click OK and connect it. You can see Chandan is getting transmitted here. Everyone can see it.
Yes.
Yes.
Okay, fine.
Yes.
Okay, I'll just disconnect it now, as we have to cover more topics today. If you want, I can share this code, but there is nothing much in this code, just 2-line code. And I have already shared the UART interrupt code, so if that works, it's easier. Similarly, you can receive and transmit using this. It's easier than interrupt because you don't have to make a interrupt callback here. So I hope everyone understood working of UART in polling mode also.
Yes.
Yes.
So now I'll just delete this.
But
Can
Chandan,
you tell me?
in this case, we
Yes.
are seeing the value in console. But how to set the value in RX buffer?
Sorry, in RX buffer, just
Yes.
transmit. So for that, just copy paste this code. Not in the while one loop. I'm just pasting it here. 1 second. Here you will receive only 1 byte, but I'll show you quickly.
Yes, that's the case because here
RX.
we only get 1 byte of data.
Yes. RX. Same thing, and I'll just do this.
I think Chandan, you have not created RX buff.
Oh, yes. Fine. I'll keep it. and just writing this code, you will receive. But what will happen if you will use receive here? Then in this buffer, you will only receive 1 byte. For example, if I will send Chandan, then what will happen? This will happen too fastly, so that once you will receive C of Chandan,
Hmm.
after that 1 second will pass and the transmit function will get its call. So you will receive only 1 byte. What you have to do this, you have to make checks, like if all you are transmit or if tx buff is transmitted successful, only then UART will receive. The same thing which I have made in UART interrupt code.
Chandan, you have shared the same code, I think, last time. So I have checked the same code like a
No,
whole
no.
okay, double equal to
Uh,
whole okay.
that same code was not sent.
Okay.
Yeah, you can check it. It will be not same. So just to do this, I think in user code line 4 here, and make checks like if your transmission is successful, then it will receive. Do
Okay.
this and you will receive it. If not, then I'll tell that also. But I want you guys to practice and do these things. And I
Okay.
have
Okay.
already taught you how to receive and transmit in UART interrupt mode. So I don't. I think you should try at least once or twice. Then, if not, you will be able to receive these things. I'll teach once again. But till then, I want all of you to try it.
Okay. Thank you.
That's why I'm not sharing this polling code. I have shown you all guys how it works and how my data is getting transmitted and received at Docklight. So just try it once at your end, then we will talk. Fine.
Okay.
If anyone have any issue, you can speak, or I'm going to delete this project. Fine. Now, I want you all to be ready with your notebooks because we are going to learn new topic today. So everyone have their notebook with them. I have already told you that you should be
Yes,
at
sir.
least
Yes,
keep it
sir.
so that you
Yes.
can cover the main points which I will teach. So all of you, if you are not having it, please take it. I will give a break of 1 minute for that. Tell me once everyone have it. Can I start?
Yes, sir.
Okay. So
Okay.
just confirm me. uh, How many of you are having notebook with you, or any pen or paper? Because the topics which I'll be teaching, you will not remember it thoroughly after some time. So you need to have it and note down the important points. So
Yeah, I had it.
Hatim, Padma, Sudhir. Okay,
Yes, sir. No, even I had.
okay, okay. Okay, so till now we have covered LED toggling, correct?
Yes.
Then toggling of LED and controlling it using switches.
Yes.
After that, we have covered PWM.
UART.
Yeah, I'm first covering topics of LED. We covered PWM. Then in PWM we covered two parts. One part where we generated PWM using only software, and one part where we generated PWM and changed the color of our RGB LED using the actual PWM configurations. Correct? Sudhir, if you can please keep your mic mute while you are talking.
Okay, sir.
Okay. Then after that, covering all these parts, we started our protocols and we covered UART protocol. We successfully learn about the theory part of UART in all three modes: interrupt mode, polling mode, and DMA mode. Correct?
Yes.
Then we transmitted data using UART in interrupt mode and received it.
Yes.
Then we covered polling method. We transmitted data and receiving it. Or I have given you these things. It's same.
Yes.
Okay. So after UART, we will cover I2C. So anyone know what does I2C means in embedded system?
I2C is integrated circuit.
Off-duplex serial communication.
Off-duplex, sir. It is yes.
Multi-master,
Yes.
multi-server.
It's also
Okay.
communication.
So yeah.
Short distance, sir.
Yes. So I2C, it is a two-wire communication protocol. Okay, when somebody asks you what is UART, what is I2C, you should not just tell its full form. Like UART is Universal Asynchronous Receiver Transmitter, or I2C is Inter-Integrated Circuit. No, these are full forms. When someone asks you what is UART, you should say it is a two-wire communication protocol where RX and TX pins are available and data is communicated in three modes, and you will all explain all these things. Correct? So never just explain the full form when somebody asks you. During your interviews also. Am I clear?
Yes.
Okay. Now coming to the I2C, its full form is inter-integrated circuit. It is a two-wire communication protocol. Fine.
Yes, sir.
It have two pins, SDA and SCL. Write it down. It have two pins, SDA and SCL. SDA stands for data. Okay. At least reply.
Yes, sir.
Yes.
Yes, sir.
Yes. So SDA stands for data pin and SCL is clock pin. So if you want to send data, which pin will be used? SDA. And when you want to synchronize or asynchronize the clock, SCL pin will be used. And there are only these two pins which will be used in I2C.
Yes.
Okay. Then there is a concept of master and slave in it. So anybody know what does master and what does slave means?
Master means microcontroller code, and slave means
No,
like,
I want in layman language.
okay, so master means a main person.
Master means
Master
someone who
gives
give
the
command.
instructions to slaves. Commands
Yes.
will follow
Will
the
take the initiative.
Yes. So master means the one who have all the authority and who will give commands. And slave will be the one who will follow the commands sent by master. Correct?
Yes.
Okay. So I2C works on master and slave communication. Here one device will be master and one device will be slave. And what will happen? Master will have SDA and SCL pin, and slave will also have SDA and SCL pin. But master will decide when the data will be sent or when the data will be received. And if master says I have to send the data, slave will have to follow its instruction and it will receive the data. Fine.
Yes.
In I2C, we can use multiple devices.
Means
So what?
Yeah.
Yeah. So what will happen in I2C? If you configure one device as master and
okay.
8, 10 or many devices as slave, then what will happen? This is called one master and single master, multiple slave.
Okay.
Okay, so what will happen? This single one master, it will control all the 7, 8 or for example 10 slaves. So this one single master will control all these 10 slaves.
But Chandan, for 10 slaves, do we not require 10 I2C in
No,
master?
no.
Okay.
I'll tell you how it works.
Okay. Okay.
So what will happen? Suppose I'll have one master. It have 2 pins, SDA and SCL, correct?
Okay.
And the case where there will be multiple slaves. So these slaves, the single clock pin of this master, it will be connected to all the slaves clock pin. If I can get
Okay.
you some, one second, I'll show you some pictures. Fine. So here in this section, you can see this diagram.
Yes.
Okay. I'll just open it. So here you can see this diagram. Just forget these two masters because right now we are talking about single master and multiple slaves, correct?
Yes.
So just forget about master 2 and master 3. Consider as they do not exist there. So what we have right now, this single master and these 3 slaves.
Okay.
Okay, so master 1 data pin is connected to slave 1 data pin and master 1 clock pin is connected to slave 1 clock pin. Okay,
Okay.
Okay.
similarly this data pin of master 1. This is connected with data pin of slave 2 also. You can see it, this pin coming down and then getting connected here.
Okay.
See, and its clock pin is also coming down and getting connected here.
Okay.
Similarly, its data pin is coming down and getting connected with the data pin of slave 3, and its clock pin is coming down and getting connected to its clock pin.
Okay.
Right?
Right.
So what will happen here? This single master, it will control all these 3 slave pins.
You mean
Yes.
in single wire we can connect multiple devices?
Yes,
External
just
devices.
put some jumper wires and you will connect it.
Okay.
Okay. So now what will happen? There is a theory, and I will teach you in detail. But I'll just give you overview right now. So what will happen? This clock pin, this pin is responsible for transmission or receiving of data. For selection of slave, this clock pin is used. How? If this master wants to communicate with slave 1, then this slave pin will get down, so its pulse will get down and communicate with slave 1.
You mean clock signal?
Yes, yes, its clock signal will get down and communicate with clock pin of slave 1.
Okay.
Similarly, if this master wants, no, I want to communicate with slave 2, then this clock will get down and connect with, so this clock will connect with slave 2 and it will make its clock pulses low. Whenever master wants to initiate transmission, the clock pin will get low.
Okay.
Like I have shown you how to make any pin high or low while we were using switches and LEDs. So if suppose pin PB is clock pin, so whenever we want to communicate, we will have to make this PB pin low. Similarly, this master, if it wants to communicate with slave 3, it will send the low clock pulse to slave 3 and communication will start.
Like master will do it.
Yes, master will send the command by lowering its clock pulse, and then communication will start with that particular slave.
Okay.
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 Only one time, one master will be communicated with one slave, or if I want to communicate with slaves,
In this case, we are having only one master and multiple slave. So this one master will communicate with all these slaves one by one.
not at the same time, right?
Yeah, no. How can it communicate at the same time if it have only one clock pin? If that clock pin is busy with slave 1, it cannot communicate with slave 2 or 3, na? Fine.
Okay. Chandan, just have one question that how master tell the clock pin that you have to communicate slave to? Is it based on
We will write the code for that.
Okay.
Like we are the coders, right? And now I want that my IC1 should communicate with IC3. So what I will do? I will write a code where I will lower the pin of IC1 and communicate with IC3.
Okay.
Okay.
Mhm.
Yeah.
Now the second case comes where right now what is happening here? One master is having multiple slaves. So this condition is known as single master and multiple slave. Okay. Now there is another case where there is multiple master and multiple slaves, which is shown in this diagram. So what happens in multiple master and multiple slaves? We have multiple masters and multiple slaves, and all these masters can communicate with all these slaves depending that it is free. For example, you are a group of 10 people. Okay. Out of these, 3 people are master and 7 people are slave. Fine.
Okay.
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 So,
So let's say A, B, and C. They are master, and after that, everyone is slave. So if A wants to control slave D, then what will happen? It will check, is it working for someone else, like for master B or C? If it's right now working for master B or C, then it cannot take its command. So it will wait till the slave finishes the task of other master. And
Okay.
if it is not performing any task, it's free, then it will communicate with slave D. Similarly, every master will check if it's free or not, and if the slave is free, it will communicate with that particular slave in the same manner. It will lower down the clock pulse and send the signal to that particular slave. Then that particular slave will communicate with it. So in this example, what's happening? There is 3 master and 3 slave. Master 1,
okay.
master 2, master 3, slave 1, slave 2, and slave 3. Okay.
Okay.
Now, what's happening here? Can anyone explain me?
In this I mean 2-wire, multiple slaves can work simultaneously with the help of multiple
So
masters.
what's happening here? Master 1's data clock is connected with slave 1 data clock. Master 1 clock pin is connected with slave 1 clock pin. Okay. Master 2 data and clock pins are connected with slave 2 data and clock pins. Similarly, master 3 data and clock pins are connected with slave 3 data and clock pins. Fine.
Yes.
Now previously what was happening? The clock pin of and data pin of master 1 was connected with all these 3 pins, all these 3 slaves.
Hmm.
In the previous where we learn about single master and multiple slave, these masters, both pin were connected with the 2 pins of all these 3 slaves. Correct?
Hmm.
In
Yes.
this case, master 2 data pin is connected with slave 2, but also this master 2 data pin is connected with slave 1 data pin and slave 3 data pins. Can you see it?
Yes.
Similarly, clock pin of master 2, it is connected with clock pin of slave 2, connected with clock pin of slave 3, connected with clock pin of slave 1. So if it wants to communicate with any of these slaves or master, it will send the command and the communication will happen. Fine.
Yes.
So we are clear that I2C stands for inter-integrated circuit, and it is a serial communication protocol that used to connect multiple devices together.
Yes.
Okay. It works on the architecture of master and slave. Master is someone who will send the command and slave is someone who will receive the command.
Yes.
Okay. We can configure our device as single master, multiple slave, or multiple master and multiple slave.
Okay.
Fine. It works on 2-wire interface.
True.
What are the names of its 2-wire?
SDN.
SCL, SDA,
SDA is data pin and SCL is clock pin.
clock pin.
Okay. Since it uses clock, So what type of communication it will
Synchronous.
perform? Synchronous or asynchronous?
Synchronous.
Synchronous. Okay, because it is using clock signal and its synchronization will be performed with clock pin.
Yes.
Okay. Now, what is the type of data transmission that will happen here? Single direction, both direction,
Bidirectional.
Bidirectional. Both
Bidirectional.
bidirection. So what will
Bidirect-
happen here? Data will be transmitted in both direction, but not simultaneously.
Yes.
Okay, so we can transmit and receive the data in both direction, but at one time only one thing will be performed, because clock pin will be either we can lower down our clock pin or we can high the clock pin. For that purpose, it will perform both direction data communication, but one time at once.
Okay.
Okay. Now we have already seen how it works on master and slave and all. Can you tell me what is the maximum speed that it will have?
1 MB per second. 400 kilohertz.
Oh, sorry.
1 MB per second. 400 kilohertz.
We can use it in modes like standard mode, fast mode, and fastest mode, and high speed mode.
4 modes.
100 to 400.
High speed mode.
So
that is up to
in a standard mode, what will happen? It will transmit data up to 100 kilohertz per second. That is around 100,000 bits per second. In fast mode, we can use it for 400 kilohertz, and maximum speed we can use it for around 3.4 megahertz.
Okay.
Okay, there are some data registers or data frame in I2C. It is I2C. So what will happen? It will have some registers. So it will have and yeah, the address by which it will select the slave, that address is known as slave address.
Okay.
Okay, so there is a term slave address, a unique address that identifies the target slave. It will be of around 7 bit or 7 bit or 10 bits.
Okay.
If I can find, okay, once I'll explain the theory, I will show it to you. Fine.
And then in terms of speed, so when to select which speed, like standard, fast?
Always use the fastest one.
Okay.
There are configurations which are provided. For example, you have to visit from your home to your office, correct?
Okay.
So you can go there by the standard speed, high speed, or fastest speed. So what you will choose?
Fastest.
It will depend on your mood. If you want to go slowly, you will go slowly. If you want to reach at that in less time, you will go into the fastest mode. Similarly, if your work or project requirement is that the data transmission should be smooth and there is no pressure of timing, you will use the standard mode. If it requires the data to be in fastest mode, you will use that fastest mode.
Okay. So will it impact the battery life or power
Yes,
consumption?
not that much. It will impact the processing speed and all,
Okay. Okay.
but not that much.
Okay.
Okay, so just write it I2C data frame. It is the most asked question. Whenever you will give interview or tell anyone about I2C, they will ask what is the I2C data frame components. So just write it and then I will show you on if I find some photographs on Google. Fine. So first is the first in the I2C data frame is start condition. Tell me once you are finished.
Yes.
Yeah.
Okay. So first is start condition. It is a condition when our data line goes into the transition of high to low. So we have two lines, data line and clock line. Fine. When my data line will at normal, my data line and clock line will remain high. So when my data line will move from high to low, and my clock line will be high. So what will be there? My data line will be coming from up to down, and my clock pin is at up. So at this condition, it is called start condition. It means the transaction of new communication is starting here. So for that, it's called a start condition. Any doubt, or am I clear?
Yeah, it's great.
So start condition means the data transferring will start now. Is it?
Yeah.
Okay.
So at that time, what will be happening? The data pin, it will be going from high to transiting from high to low transition.
And clock should be
My
high.
clock pin will be high. Fine. Then the second one will be slave address, because the command will be sent from my master. So it must assign some slave address to choose which particular slave I am using. So the second condition is slave address. It is of 7 bit or 10 bits. It depends. So once you write it, let me know.
Depends on slave.
Slave.
The slave address which you told.
Depends on slave whether it will be of 7 bit or 10 bit.
Okay. Okay.
Okay, so slave address is a unique address that identifies the target slave address or the target slave device.
Okay.
Okay, then there will be a read-write byte.
Sorry.
Read.
For the start condition, SDA will be initially 1 and SCL will be high, also 1. So when the communication is starting, then SCL becomes low, right?
Yes, but the transition when my SDA pin will be moving from high to low, that period is known as start condition.
Okay, at that time SCL goes to high, like 1.
No, my SCL will remain high initially, and SDA pin will also be at high condition initially. Fine.
Okay.
Now, that when the transition takes place, that my SDA pin for giving the command or for giving the data, it will go from high to low transition. That period is known as start condition.
So SCL remains same, but SDA.
Yeah, at that time SCL remains same and SDA moves transist from high to low.
Okay.
Okay. Now slave address, I have told you about this. Third one is read write bit. It is a single bit that indicates whether the master wants to read or write. Okay.
Okay.
I2C performs both operation, like it can read or it can write. So who will decide it? Obviously master will decide. So there is one bit, that is read write bit, that will decide whether master will perform the read operation or master will perform the write operation. Now the fourth data frame is acknowledge and not acknowledge. You can just write it ACK or NACK. We will use in the code same ACK or NACK. ACK stands for acknowledge and NACK stands for not acknowledged.
So Chandan, in read and write bit, so for read it is high or low?
To read it will be 1 and to write it will be 0.
Okay.
Now acknowledge bit, it is a bit that will be sent by receiver to indicate that it has successfully received the data. Okay, for example, once my master has given the command to the slave and it will transmit the data. It will write the data. Okay, so whether the data is successfully received by slave or not, who will confirm it? This acknowledgement or non-acknowledgement bit. So if my acknowledgement bit is low, it tells that successful data is received, and if the acknowledgement bit is high, it tells that it have not acknowledged and it have not received the data. Then comes the fifth part, data bytes. Till now what we have done, we have started the condition, we have selected our slave using slave address, we have selected whether the master wants to read or write. Then the receiver have already initiated a bit which will tells whether it have acknowledged or not acknowledged the transmission. Then comes fifth part, that is data byte. Data byte is same in all communication. It is a data which we want to transmit between master and slave. And then there will be a stop condition. Okay. So in a start condition, what was happening?
High to low.
Data pin was transitioning from high to low. So in a stop condition, the same pin will transition from low to high, and it indicates that transmission is successfully completed, or it indicates that the transition have come to an end. So these are the components like a start condition, slave address, third one read write bit, acknowledgement, not acknowledgement, data bytes, and stop condition. There is one more condition in the data frame, that is acknowledgement or not acknowledgement bit. So previously we have learned that acknowledgement or not acknowledgement, what it tells, my data is successfully transmitted or not transmitted. Then there is another one, that is acknowledgement or not acknowledgement bit. Similarly, it will acknowledge that after every receiving of bit or transmission of bit, it will send that whether it have received that one bit or not.
So
Fine.
the data will be transferred like in bits, right? 8 bits, one by one. So
Yes.
if the data is transferred, I mean half data is transferred, like 4 bits are transferred. In the middle, some due to some issue, it got stopped the communication. At that
Yes.
time, what will happen? Like the communication restart, or the where the communication stop, the remaining bits will transfer again.
One second. So my 4 bit of data have been successfully received, correct? And after that, my data communication is not received. That's your question?
Yes.
Okay. So what will happen? The bit register, acknowledgement or not acknowledgement bit, it will be set. It will acknowledge that I have received one bit 4 times. That means it have received 4 bits successfully. Okay, but the overall acknowledgement or not acknowledgement bit that was getting set or reset when complete data was received, it will not acknowledge. Correct?
For every bit, does it acknowledge or overall?
There is two acknowledgement and non-acknowledgement bits. One is the fourth one, that is ACK or NACK bit. What it will do, it will acknowledgement that it have successfully received the data or not, means complete data. And the another is ACK NACK bit. For each byte, it will acknowledgement that each bit of data have received or not. For example, if I am sending Hatim, fine, so it has HATIM. So the first acknowledgement bit, it will get set only when it will receive all this complete data, HATIM. Only then it will acknowledge that it have received the data. Fine. But the second one, it will be first it will receive H, it will send acknowledgement. Then it will receive A, it will again send acknowledgement. Then it will receive T, it will again send acknowledgement. So the second one will work like this.
Second one in the sense?
Yeah, that's correct.
Like second one in the sense what, sir? Like, is it a type of acknowledgement option?
Everyone can see the screen presented by Hatim here.
So it's a start condition, then
Yeah.
address, slave address.
The address, slave address. Then third one is read write bit. Fourth one is the first acknowledgement or not acknowledgement bit. Okay, so this fourth acknowledgement or not acknowledgement bit, it will get set or not set when it will receive the complete data. And the second acknowledgement, non-acknowledgement bit, it will get sent after receiving of each byte of data.
So what does mean 8 bytes here? Chandan?
It's the data frame. For example, I am sending data that is bigger than 8 bits. So what will happen? The data will be sent in the chunks of 8 bit, 8 bit, and 8 bits. So it's just dividing it.
So for example, we are passing Hatim, then this 8 bit
Only
define
the
H?
first one will be sufficient for it, because Hatim is of 5 bits. It will be in first 8 bits only.
Okay.
So we will not need the other one.
Okay, so if it is more than 8, then it will send acknowledgement on every 8 bits.
So it will first receive the 8 bits, send the acknowledgement that it have received all the 8 bits.
Okay,
Then again it will receive the 8 bit and send the acknowledgement that it have received all the 8 bits. And the last acknowledgement
At a time or bit by bit? One bit transferred, acknowledgement, one bit transferred, acknowledgement, like that, or all the bits are transferred, acknowledgement?
I think you are getting confused. Here we have two acknowledgement or non-acknowledgement registers. Okay, so the first register of acknowledgement and non-acknowledgement, it will acknowledge only when it will receive all the 8 bits of data. Okay, and the second one, it will acknowledgement after receiving of each byte of data. For example, I have your name is Padma, correct? Hello.
Ritika.
Okay, you have joined using.
Yeah, some other right.
Okay,
Yeah.
so no issue. So your name is Ritika. Okay. RITIKA, correct?
Yeah.
So it's of 6 bit.
Yes.
Okay. So the first acknowledgement register, it will acknowledge only when it will receive all these 6 bits, because it's less than 8 bit. So it will acknowledge only after it will receive all these 6 bits. But the last one you can see on this message data frame, acknowledgement, non-acknowledgement bit. So it will acknowledge 6 times. First when it will receive first when it will receive R, then when it will receive I, then T, then I, then K, then A. Okay. So I think it's clear now.
Yeah.
Okay. So that's it regarding the I2C and its transaction.
Sir, in this all this like in all this data frame, where the SCL will become low, sir, to get access for the particular slave.
When we want to initiate the communication.
Like when it will happen, like after start condition or
No.
after passing lines?
It will happen before all these 7 conditions.
Oh,
Okay. The HCL pin will select the slave. So it will
after
get
that
low.
only?
It will get low and it will select that I have to start the communication now. Then all these things will take place.
Okay.
Fine. And it's so for today we will end with only this theory part. In tomorrow's class we will see the hands-on workshop of the I2C communication. Till
Okay.
now, if anyone have any doubt, you can ask, or we can end this session right now.
Sir, I didn't get this acknowledgement, non-acknowledgement thing actually. Like after
There,
passing,
I'll suggest you should just Google it
okay.
and just read 1 or 2 articles. Still, after that, if you cannot understand it, then in next class, tell me. I'll once again repeat it.
Okay, fine.
Okay, fine. So now we will end this session.
Yeah. Now we can. Yeah. We can.
Okay, fine.
Yeah. We can wind up to here only. If you guys have any point, any doubt, then we can meet again tomorrow with the same time. Okay. So thank you, Chandan.
Thank you.
Hello.
Yeah. Thank you. Bye.
Actually, I bought one STM board like L412RB. I'm facing some issue in the schematic. I couldn't able to find few pins. So now I'm having some disturbance here. Is that fine? Can I ask tomorrow?
Yes.
Yeah, you can ask tomorrow, or you can send the picture of your controller.
I'll share the controller and I'll rectify my issue tomorrow.
Okay, no issue.
Yeah, thank
Yeah,
you.
one more thing. Last time you had mentioned.
Yeah, you sent me, but I did not get the time to look into it. Tomorrow it's Sunday, so it's free time for me. I'll look into it and will share with you.
Chandan,
Yes.
I want one favor. If possible, you can send some YouTube videos regarding the register level things work behind the scene, so we can understand the concept more, if possible.
Okay, registered level seems like what?
Like, for example, address. So we have 32-bit microcontroller.
Yes.
So, like, we have starting address of I2C slave.
Yes.
So if we want to communicate with external sensor, so I
Okay.
think we need to understand the register level programming.
Yeah, that I will show in after 2-3 classes.
Okay, so it will cover in our course. Okay, that's great.
Yeah, I have in the course content that I have shared, it's mentioned that I will show communication of I2C with STM32 controller board, and then I will show the communication with one external sensor also.
Okay, fine. Okay.
Yeah,
Okay, thank you.
thank you. So now I'll end it.
Like without API, if you want to learn that one, you can suggest.
Without API,
Yeah,
I mean, all.
Hall libraries.
Hmm.
Yeah, so for that you will have to learn register level coding, but you
Yes.
cannot learn it without learning HAL library coding.
Yeah, parallelly we can if you
No, you cannot learn it parallelly. First, you will have to understand HAL level library or any first one level library like HAL level library, BSP level library, anyone. After that, you can learn the register level coding. That I'll
Okay.
teach in some sense. I2C I will teach it, and
Okay.
at some sensors I will teach it also.
Okay.
Fine.
I'll suggest you should just go through the course content once. You will all your doubts and queries will be solved
Yeah.
regarding this.
Okay then.
Okay.
It will call.
Okay then, we can wind up to here only, and we can meet again tomorrow with the same time. Okay. And
No,
then
fine.
meantime, you guys have any doubt, you can post the query in group. Okay.
Fine, sir.
Okay then. Thank you.
Okay.
Thank you everyone.
Then bye.
Thank you. Bye bye.
Thank you.